All right, section 1.2, we want to cover a couple important properties of limits on slide number 15. So, a couple important properties of limits. All right, so if I have the limit as x approaches c of b, some constant, times f of x, then we can rewrite this as b times the limit as x approaches c of f of x. So we can pretty much just factor out a constant outside of a limit. All right. So one property. All right. Another property. The limit as x approaches c of f of x plus or minus g of x. Well, if I have two functions added together or subtracted, then I can simply take the limit as x approaches c of f of x and then add it or subtract from the limit as x approaches c of g of x. So if I have two separate functions added or subtracted together, then I can simply add or subtract their limits. All right. Now, okay, basically the same thing is true with the product of two functions. So for instance, if I have the limit as x approaches c of f of x times g of x, then I can find the limit as x approaches c of f of x times, and then the limit as x approaches c of g of x. So I can find their limits separately and then multiply their results. All right, now, of course, you would probably assume that the same is true here. We can take the limit as x approaches c of f of x and divide it by the limit as x approaches c of g of x. So we can find their limits separately and then divide their result. Now, it's important to note that this does work unless you get the 0 over 0 situation, and then obviously we need to do some work like we did in section 1.1. All right, now what if we have the limit as x approaches c of f of x to the nth power, right? So to some power, right? So second, third, fourth, or like 1/2, 1/3, something like that. All right, then what can we do? We can take that power outside. So that means I can evaluate the limit as x approaches c of f of x, and then take the nth power of whatever that result is. Okay, so this is particularly useful when you have something like the limit as x approaches c of the square root of f of x. We would then rewrite that as the square root of the limit as x approaches c of f of x. So we would evaluate the limit of f and then simply take the square root of that result. All right, and then lastly, okay, kind of a just a more general thing of the previous one. So if I have the limit as x approaches c of f of g of x, well, just like we took the n outside of the limit, we could take the f outside of the limit, and so we can evaluate f of the limit as x approaches c of g of x. So we can find the limit as x approaches c of just g, whatever that number happens to be, and then evaluate f of that number. All right, so a couple examples. Okay, we're using these graphically, but they could also work numerically or analytically as well, but these are the examples that we're going to use. All right, so the limit as x approaches 2 of g of f. So what does that mean? We're going to find the limit as x approaches 2 of f and then evaluate g of that. So let's go here. We have f. What is f of 2? So f of 2 is 1. And so I want to evaluate g of 1. So g of 1 is 1. So that would be the limit. Next, the limit as x approaches 1 of g of f. Once again, f of 1. So we want to evaluate the limit as x approaches 1 of f. So here's f. That limit is 2, right? And so I'm evaluating g of the limit as x approaches 1 of f of 1. So what is f of 1? Well, that's 2. So g of 2 is, go down here, g of 2 is 1. Now, I understand that sometimes people look at this and they say, well, but the limit as x approaches 2 doesn't work here. Well, we're not evaluating the limit as x approaches 2. We're evaluating the limit as x approaches 1 of g of f of x. And so it's important that we understand that we brought the g outside. So g is not part of the limit anymore. All right, so now limit as x approaches 2 of g of x over f of x. So g of 2, the limit as x approaches, so I'm going to rewrite this here, limit as x approaches 2 of just g. Well, what is the limit as x approaches 2 of just g? Well, that limit does not exist. So we have a non-existent value divided by the limit as x approaches 2 of f. Well, of course, the limit as x approaches 2 of f does exist. It's 1, but this does not exist because the limit as x approaches 2 of g did not exist. Now, notice the difference between these last two examples. This one was evaluating the limit as x approaches 1, which does exist on f. And then we evaluated g of 2. All right, what about this one? Okay, kind of the example that I gave on the previous slide. The limit as x approaches 2 of the square root of f. So we're going to evaluate the square root of the limit. Well, what is the limit as x approaches 2 of f? Limit as x approaches 2 of f is 1, so the square root of 1. So our answer is 1. And then here, kind of the same idea. We're going to take the limit as x approaches 2 of g, and then we're going to cube that result. So what is the limit as x approaches 2 of g? Well, that limit as x approaches 2 of g, that does not exist. So does not exist cubed, well, of course, that does not exist.